Hello, my name is Jing Vergara. I am a principal software engineer at Salesforce. I'm part of the organization that paves the path for continuous delivery into multiple public cloud environments. I work with the different internal engineering groups to capture release requirements from these different business units. Our Spinnaker teams then build extensions and capabilities to enable all of these requirements. Have you ever wondered what it takes to run a successful CD or continuous delivery platform like Spinnaker at an enterprise-level scale company like Salesforce? We started Spinnaker evaluation a couple years back, and today I'd like to share our journey with Spinnaker and the lessons we learned along the way. I will be focusing on three main topics. I'd like to share our Spinnaker footprint at Salesforce, the top challenges that we faced, and our long-range plans. So can you guess how many Spinnaker instances we have at Salesforce? If you guessed 1, 2, or 3, unfortunately, that's incorrect. We actually have about 4 Spinnaker instances, and that number continues to grow. The main reason for having many Spinnaker instances is to minimize the blast radius. We have what we call high secure zones, which are built up of isolated environments wherein it cannot be reached by any other Spinnaker instances. So we have to build a Spinnaker instance for each of these zones. We cannot have one global Spinnaker instance that can rule them all. Because of this architecture, we are also have to go and split our image baking activities from our deployment activities. We want to make sure we have a single image that we would distribute across all of these different instances. So we have, again, the image baking environments and the deployment environments. When we started with Spinnaker at Salesforce, we also started with deploying to pre-production environments. These pre-production environments are internal environments that handle our development and testing of the pipelines and all of these software versions. So we use them for integration testing, for performance testing, and such. During this time period, we have actually studied how Spinnaker can handle the different scale and load capacities that we have. So once we've actually figured out what it would take for Spinnaker to run, we've built a production environment that will handle all of the production usages. So we have a split environment between our pre-production target environments, and we have one for our production environments. Currently, our pre-production environments have about 30 to 50,000 executions per day, which is about 1.8 million per month. And this number continues to grow. And in production, we have about 5 to 12,000 executions per day, which is about 200,000 per month and growing. We are forecasting that production's usage will grow more than what we have in pre-production very, very soon. Spinnaker, as we all know, supports different cloud providers. And at Salesforce, we use about 3 substrates or 3 cloud providers. We also have a lot of Spinnaker applications across all the different engineering teams within Salesforce. So we have about 1,000 of them. And each of these applications, together all of them, we generate about 50 to 60,000 pipelines, typically related to each environment that we have per service. And then they are generated from about 5,000 pipeline templates. So based on these 5,000 pipeline templates, we pre-generate all these 50 or 60,000 pipelines. And we have thousands of Spinnaker accounts, which would include both EC2 and Kubernetes accounts, or VM and Kubernetes accounts that we have or support. At Salesforce, we also noticed that our customers or the service owners actually perform similar sets of activities. And based on these changed activities, we have categorized them into these pipeline types. The first one would be the generation of the VM images. And again, we use baking pipelines for this. So for example, for AWS, this would be the AMIs. And for Google Cloud, this would be the GCE images that would need to be able to run on the GCE VMs. And then for deployment pipelines, we support, again, both Kubernetes and VMs. So we deploy to these two technologies. And then for setting up or building cloud resources, we have what we call resource provisioning pipelines for them. And then to tear down these services and resources, we have the service decommission and the resource destruction pipelines. We also have other pipeline types, and some of them we call like the test validation pipelines, which are typically used for testing services or environments or resources. And then the catch-all would be something like a utility pipeline where service owners can use them for patching, for capacity, like increasing capacity, decreasing capacity, or if they have stateful services, then they can use that for their database backup and restore. Now that I've shared how it looks like with Spinnaker at Salesforce, I'm gonna present the different challenges that we faced when we went from the proof of concept all the way to production. So the first challenge that we had was we didn't know how we can build pipelines from an environment bill of materials before. So what's an environment bill of material? An environment bill of material is a list of configuration files that describe what environments do we need to apply the changes to, and what are the configurations around those environments. So think about what regions do we need to support, what are the account numbers for those, what are the IP addresses, what type of resources we need to build. So think about in those concepts. So we have those, and we need to be able to generate the Spinnaker pipelines based from those configurations. So what we did was we created our own template management system that can handle or read these bombs, and then via GitOps workflow, we check in those configurations. It gets delivered to our production or Spinnaker instances. And then we have our template management system that reads off of those and calls the Spinnaker API to generate the pipelines from those. Again, we need to have different templates for all the pipeline types that we would need to support. To validate all of these templates, we enforce OPA policy checks against these templates to ensure that they follow the standards that we have set for the company, to make sure that they are secure and that no one's skipping a step that must be done for every pipeline run. We also had to support pipeline template versioning for these templates to ensure that for any change that any team has, it goes through the slow or gradual rollout process to ensure that if something broke in the pipeline definition, we test that earlier on in the dev or the pre-prod environments before they actually make its way to production. The second challenge that we have is that, okay, we have multiple environments, then how do we orchestrate the releases across all of these environments, right? It's going to be painful for a service owner to go into a Spinnaker UI and ask them to say, you have to click on however many environments you have. So for example, a service owner would have 100 or 1,000 number of environments. We can't expect them to start all the executions one by one on all of those environments. So what we've done around this is we came up with a concept of deployment manifest and master pipelines. So the deployment manifest would describe what artifacts would need to be deployed into which environments. And then we pre-build the master pipelines, and that would show how we would set the canaries and the staggered rollouts across all of those different environments. The third challenge that we have is that how do different teams keep track of all the changes that go through the Spinnaker? So we need these for auditing and compliance. And then we have the other personas, like the service reliability engineering, and they typically debug issues for a particular environment. So all of these different teams would want to know what happened along the way during these pipeline executions. So to keep track of all the changes that go through, we have integrated with our change management system at Salesforce. In there, we attach all the change lists or pull requests that we have for a particular change. And we include a deployment manifest that, again, would include the artifacts in the target environments. And then we also attach data, test data, and results. We've also pre-generate all the change case records for the different service owners so that they don't have to manually build these change case records. It especially gets, again, very, very hard if we're talking about hundreds to thousands of environments that we need to go deploy to. And then for the site reliability engineers, they actually have another problem. Within Spinnaker right now, you can only see the pipeline execution for one application at a time. There is no cross-application or global application view. So we need to build this view for them so that they can detect what change actually went through for an environment given for a particular point of time or a window. The fourth challenge that we have was on failure handling. So now we can handle the release orchestration at scale. But what if one, a couple, or a few environment deployments or changes actually fail? Would that mean starting all over again? So if you have 1,000, 5 failed, you have to repeat all the 1,000 again, right? That doesn't sound optimal at all. It's very painful, right? So what we've done at Salesforce is we introduced the concept of master pipeline idempotency. We keep track of the states of all of the stages or executions that have run. And so we look at a deployment manifest and check whether we've already executed that before. If we have and it succeeded, then we skip those targets and just continue on with either the failed or the incomplete ones. We have also added some logic within the pipeline execution, some failure handling, like pipeline retries, or the ability to ignore failures. So this allows the service owners to go either manually resolve those failures, or they can set in their configurations whether they want to enable those to be automatically retried or automatically ignored. We also wanted to put some automated rollbacks in there. So for those systems that use like red-black strategy and the old infrastructure is still available, we'd like to switch back right away whenever there's a failure. The other challenge that we have is on infrastructure builds and changes. So typically, you would think that, oh yeah, Spinnaker continuous delivery platform, it can only handle software upgrades, right? But at Salesforce, we use it for more than that. We also use it to orchestrate infrastructure builds and changes. So we use the other open source tool called Terraform, which is basically infrastructure as code. Again, it's a set of manifests that describes what kind of resources you want and what properties those resources would need, right? So we orchestrate the execution of those Terraform code using the same set of master pipelines that we use for service upgrades as well. And the sixth challenge that we have is around Spinnaker account management. So at Salesforce, we had a tremendous growth of accounts as teams from one group to another started onboarding onto our system. initially we only had like a handful, and then in the tens, and then in the hundreds, and eventually into thousands. And then there was a point in time when Spinnaker cannot handle any more new accounts. So we had to go and create our own init and sidecar containers for Cloud Driver and Roscoe to handle all those accounts and secrets so that it can continue to work. And then we worked with the OSS team to support and improve the dynamic account handling within Spinnaker itself. The seventh challenge we had was around alerts and notifications, right? So in some cloud platform, I think it's AWS, PubSub events are not supported out of the box. So what we've done behind the scenes is we implemented Echo webhook so we can listen to those events, and we integrated it with our metric system, and we integrated it with PagerDuty as well, so that we can be alerted of all of the different events, either success or failures. The next challenge that we had was on pipeline security. So how do we secure pipeline executions? At Salesforce, we do not allow triggering of the pipelines manually in the Spinnaker UI. That's on an administrative level of permission or access. Everything has to be done via GitOps. And then in our GitOps solution, we enforce 2HA or 2 human approval, where someone else has to approve that request before it's allowed to be able to go out and trigger the pipelines in Spinnaker. We also have some manual judgment stages that ensure some pipeline executions, and we also have enabled RBAC policies within Spinnaker. The ninth challenge that we have is, how do we handle promotions? So promotions is making sure that when we go move from one environment to the other, that it actually goes and there's a stamp of approval. So we have allotted in our master pipeline certain promotion pipelines that can handle either a manual judgment where someone has to manually approve that it's good to go to the next stage. We also do soak time, wherein it waits for a certain amount of time to make sure that some regressions that are not caught in automated test can be handled, hopefully, or can be caught during that soak period. And then we also have integration with some of our automated test framework suite. And then the last challenge that we have is on the complex release orchestration mechanisms, right? So we have these requirements that, hey, you cannot allow mutually exclusive changes to occur at the same time. We have to make sure that we don't run pipelines during moratoriums, or if there's an incident, or these services can only run during these release windows. So with this, we are integrating with a locking system to enable all these complex requirements. And we have a lot more projects and problems to solve at Salesforce, and here's some list. So we are currently hiring, so if you are passionate for continuous delivery problems and distributed systems and automation, please ping me. We'd love to hear from you. And with that, I'd like to thank everyone for your time and all the best on your continuous delivery journey. Please feel free to reach out if you have any questions. Thank you. Hello, everyone. So I think we're opening up for Q&A. So if you have any questions. Looks like we have one from Tony. What automated test frameworks are people using? So for the test framework, we actually have an in-house test framework at Salesforce. So we built our custom framework. Thanks, Faye. So Faye's asking, how are people using pre-prod and prod deployment Spinnaker differently? So the difference between these two environments is that on pre-prod, we're targeting development and testing environments, while the prod deployment is where we target our production environments. So typically, they would want to go and test either their software version or their pipelines. So they generate their pipelines and they want to test it out first. Or again, if they're doing a software upgrade, they want to test it in their development or test environments. Then they go to the pre-prod deployment Spinnaker, and that's where the releases happen for those, or that's where the changes happen. Once they feel comfortable, the release manager gives the stamp approval, then they go ship it in the production environments. Thanks, Paul. So the question is, does that in-house test framework interact with Kayenta at all? We have Kayenta in our roadmap. It's not yet integrated with Kayenta, but we do have plans to integrate it with Kayenta soon. Thanks, Venugopal. Can you share a little bit about the metrics that you are capturing? So on the metrics that we are capturing different types of metric. I'm not sure which one you're particularly interested in, but we are looking at, of course, the load and scale growth that we have, because we need to make sure that we can handle all of those deployments. We're also handling the typical reads metrics, or we call that the requests, the errors, the availability, the duration, and the saturation. So those are the typical metrics that we are capturing for the service. And then as we build new features, we also look at adoption rates. Could you elaborate on the GitOps triggering you're using for promotion? Thanks, Greg, for that question. So on the GitOps triggers that we use for our promotion, what happens behind the scenes, we have our Git repo where we put all of our deployment manifests in, and then that's where they go and update the versions, or if there are automated systems, the automated systems update the versions on those manifests, or if there are new targets, then those targets get added. And then there needs to be a peer approval or a manager approval on those. And then once it's approved, then we have a system that delivers those manifests to our Spinnaker environments. And then Spinnaker, we have a listener, or the echo a notifier for any changes into the S3 bucket. So those manifests go into like an S3 bucket or GCP bucket, whatever the storage system for that cloud, wherever the Spinnaker is. And then we use that as the trigger mechanism for the pipeline. So the pipeline gets triggered and then orchestrates the deployment across all the different environments. Thanks, Kolowo, for your questions. And I think the question is, do you do automated canary analysis? We do not have automated canary analysis just yet, but we are planning to do that as part of our Kayenta integration. So we'll be doing that soon. William, question is, what are deployment strategy ratio used with Spinnaker, blue-green, canary, A/B testing? So those deployment strategies actually vary by business units. I don't have the actual ratio on which ones are being used by the different teams. Another team is actually doing that analysis. So sorry, I don't have those numbers. What about the progressive deploys? Do you do them? Thanks, Venugopal, again for this question. So what we do in our progressive deploys, or how we handle that, is that we have our master pipeline. And our master pipeline has different multiple stages, or what we call stagger groups. So think of it as the master pipeline gets triggered. It starts with, say, the development stagger group. And in that development stagger group, we're targeting development regions, right? So all of our environments that are with environment type of development gets deployed to first, and then they get deployed there. Tests are run, again, using our custom test framework. And then once that's good, then we proceed to the next stage, or the next stagger group of testing environments. So that's where we have our functional test environments, our performance test environments. And then once that's good, we move on to the stage stagger group. And then in that stage would be our production before production or similar to production environment. And then eventually, once that's good, then we go and move to the production. Okay. Faye's question. Sorry. Can you elaborate more on your RBAC? So on the RBAC, we have set admin roles. We have set read roles. We have set write permissions. So for each of those pipelines, we assign them those roles and permissions. So those are Spinnaker out-of-the-box capabilities. And then we hook them up with our LDAP system, and then depending on which team you're on, then you actually have the rights to either view the pipelines or run the pipelines or execute the pipelines. So executing the pipelines and writing on the pipelines, we only give those to the administrative user and to our service user for the master pipeline. So we do not allow anyone to run anything in production. In the pre-prod Spinnaker environment, we're more lenient, so we allow people to go and play with the Spinnaker UI. So there they can execute pipelines manually. All right, thanks. All right, I think we're done. Have a good one, everyone. Bye.